Hello, welcome to You Choose, a choose your own style adventure through the cloud native landscape. I'm Whitney. This is Victor. Hi, Victor. How you doing?
Always good. Always
Always
good.
good. We're here. This is kind of a special and different episode. This is the chapter finale for chapter 1. We made it. Looks like we made it. Yeah, we did it.
It's
Well,
more
I'm
like a
speaking too
recap, right?
soon.
It's like in
Yeah.
school, right? When you don't want to go through all the material, but you just read the summary.
This is the cliff notes. If you don't want to watch all those other episodes, you could just watch today's, and you could feel like you saw everything. Because we will do every project justice. We'll do as good of a job as the maintainers did describing their projects, I'm sure.
We'll see about that.
We will have a lot of fun. So today we're going to recap everything we've gone through. We also will reveal who won from, not won, but was chosen from last week's episode about developing an application that's running in Kubernetes. And then we're going to build the demo from end to end using all the tech that y'all have chosen. So that's pretty exciting. I'm super, super, super psyched. Also,
I don't get to use my gong today.
we can figure out a way. We can certain buzzwords, if they get spoken, they can be gong worthy. Also, my birthday's on Saturday. I'm gonna be 44 years old, and I only want one thing, Victor, for my birthday.
Amazon wish list.
I want a Victor Farsick Lego figurine. That's all I want.
You just need to give your personal company information to Upbound and
I'm just gonna stand at the Upbound booth and fill it out over and over and over again. That's all I want. We have some friends in the chat today. Rick says, "Happy early birthday!" Thank you, Rick. Yay, live stream. So glad you're here.
with
Should we get
all
started?
of the. We're so glad that you're here, excluding all the people who came 12 hours ago because I scheduled it wrongly.
Yeah. Oops, sorry. Yeah. That's okay. That's we're big fans here of just doing it and then iterating and learning, and we'll get it better. Every chapter of this will be better and better. And
Well,
and we'll,
learning is a tough word.
I guess
I'll take it.
I'm giving you too much credit. At this point, how many live streams have you scheduled? You probably should have that getting the time right lesson down.
I'm still learning about AM, PM, and stuff like that.
Yeah, I feel like apologizing for Western culture all the time. Here's another case. Like, yeah, the way y'all do it is definitely superior. 100%. I'm not going to even slightly disagree on that one. Are you ready to dig in? Should we do
Yeah.
this?
Yeah.
Let's do this. Cool.
Yeah.
So, way back when we started our journey months ago, we started with building a container image. And so then we had 3 technologies for that. We had Lima and K-Build and Cloud Native Build Packs. So Lima is a VM that is optimized to run Containerd on a Mac. It underpins Rancher Desktop. That's kind of meant to replace or can replace Docker Desktop if you don't want to pay that $5 a month that they rolled out. So the Lima implements Containerd, and which implements NerdCuddle, which uses BuildKit to actually build the image. But we're talking about Lima because that's the CNCF project at play here. So BuildKit to build an image that underpins lots of image building software, I'd say. And it's Docker's image building software, replaces their legacy builder. What else do we want to say about BuildKit? It requires a Docker file.
It's what runs on my machine of the 3.
It is? Well, there you go. It has Victor's endorsements. And then Cloud Native Build Packs. It is a technology that inputs source code and outputs an OCI compliant container image. And then what happens there in the middle can be invisible to developers who are using it, but also can be customized to the ops folks who are concerned about having consistent build strategy across their organization. So the images are...
If you think of it from the perspective of building images, it builds images just like Buildpacks, for example, does. But it has additional feature. It actually modifies your manifest with the new tag and stuff like that. So you're your manifests are already using
You're
that
talking
tag.
about K-Build now. Did I say K-Build?
I
thought I was talking about cloud native build packs.
Okay, then if one of us is wrong, it must be me.
Not necessarily. Sometimes I get so wrapped up in what I'm saying. But so the cloud native build packs is what builds inputs source code, outputs an OCI compliant container image. You can incorporate policy into that build pack, the builder, it's called, the application that actually builds the image. Or for developers to consume it, that part can be invisible for them, where they just would do something like run the pack command and it pointed at the source code, and it would use the default builder. And the default builder is going to have the build packs. Anyway, let's not get too deep in that. But and so that's basically it. Invisible to developers. It's reproducible builds. It's really easy to rebase, and the layers are swappable. So rebuilds are fast because you only have to rebuild the layers that get changed in between builds.
Correct.
And then there's K-Build, which you were talking about. Yeah. So K-Build could be underpinned by any builder. It could be underpinned by by build packs or by build kit or other builders that we didn't talk about on the show. And just like Victor was saying, it knows where your images are in your configuration and automatically updates the tags for you, so you don't have to do that step. And we have a question from Talha. Isn't build packs the thing Heroku used before everything else? Yes. There are Heroku flavor build packs, as well as Google flavor, as well as Paketo flavor, and you can build your own build packs too.
Exactly.
So yes, please do post questions as we're going. Unlike our other show format where we do all the questions at the end, we're gonna chat with y'all during the stream this time, which will be crazy fun. So y'all chose cloud native build packs from those three choices. So let's get our demo portion of the show started.
Okay, can you put my screen on?
It's done.
Okay, cool. So this is the repo. By the way, the repo should be in the description unless I forgot, and then you remind me. If I go to build container images section, blah, 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 we're going to skip all that and go straight into cloud native build packs. So I'm going to export a tag, a variable that will hold the tag, 001. I'm going to add this to settings. This is irrelevant for the demo, but it's just for the steps later if I need to remind myself what is the tag. I like to keep all the information somewhere. Now comes the important thing. First, I'm going to configure the default builder to be Paketo build packs /builder tiny, right? Paketo is one of the popular ones. And tiny tag means that it is going to give us very small images. Oh, I just realized what I did. I forgot to start Docker. So
I do that all the time.
There we go.
Classic.
There we go.
Victor, you're one of us. Yeah, we all relate
I
to
will
you
never
right now.
admit it. Okay, come on. Almost there.
You might have to hear a
there.
joke.
Yeah, tell them a joke.
Victor, where can you find a dog with no legs?
I don't know.
Right where you left it. Hey, that was a real laugh.
Okay, we're going to work on your jokes.
What do you mean?
No,
You're
you know what's the problem is that You need to tell me in advance when the joke ends, because then I can have appropriate reaction, right? A reaction like, this is so... right? I can laugh. I just need to know when to do it. You need to give a clue.
Oh, we have an oof and tough town crowd today. It's always a tough crowd day with Victor as my co-host. Am I right?
Not for me. Not for me. For everybody else. Anyways, I built an image, but I have no Docker file, right? You don't see it here. It's split screen. You need to trust me that there is no Docker file here. So essentially, Buildpax built an image by evaluating the source code and figuring out what should be the way how it should build the image. And you can see that that's true by checking cncf demo. There we go. Built 43 years ago.
Excellent.
That's a Paketo thing. You just ignore the dates. Now, and that's it. That's it. I have an image built, and now we need to figure out registries, but I'll let you, Whitney, explain the registries first.
All right. We talked about 3 different registry choices. Distribution. So distribution is like a toolkit to build registries, and it underpins a lot of registries. So it underpins Docker Hub, which would have been our implementation had that one been chosen. Spoiler alert, that one was not chosen. It also like DigitalOcean registry, like GitHub, GitLab registries. There are a lot of
even
them.
Harbor.
I was getting there. That was going to be my segue into the next one.
We'll coordinate better next time.
No, we won't. That's a lie.
You need to learn how to mute me and just kind of unmute at the right moment.
It's just like the Whitney show with like Victor just like, let me talk in the background. I could get behind that. So distribution even underpins Harbor, which was another choice that we had. Maybe there were only 2. There were only those 2 choices. No, there was
3
third.
choices.
Dragonfly. Okay, so then Harbor is lets you self-host your container image registry, and then it adds a lot of extra features. So you can scan images to make sure they're trusted. You can sign images. You can replicate registries, so that's good for geo-replication, or if you want to avoid rate limits in Docker Hub, say. What am I missing? You can role-based access control, so you can control who accesses your registry, and then you also have image retention policies that you can implement with Harbor.
Among the self-managed registries, that's the most feature-rich. It's basically the choice, period.
Yeah.
At least among open source.
Yes. It's a great choice. And then finally, we talked about Dragonfly. So with all 3 of these registry choices, they're not mutually exclusive. So Dragonfly can work with Harbor too. And so Dragonfly isn't a registry choice per se, but this just felt like the right place to put it since we're trying to cover every CNCF project. And Dragonfly uses peer-to-peer networking to be able to move large images and files, or really any images and files around your system more easily. And that didn't make sense to me when I first heard about it, but when Alan Sun came on and talked about it, he also talked about a Dragonfly sub-project called Nidus, which is a different container file format that actually can store large container images in lots of pieces. So when those pieces can be stored on different machines, it makes more sense, the peer-to-peer networking part, that they can all be pulled from different spots. So that part makes for a really fast image build. And then also with Nidus, you can build, it knows which part of the image is needed to start the container, and it pulls that part first and starts the container as fast as possible. So it's good for very fast container starts and dealing with very large container images, which Victor has an opinion about, believe it or not.
I do?
Yeah. you were like, I was like, oh, Harbor, like Dragonfly makes so much more sense now that I understand about Nidus images. This is all really cool. And you're just like, you shouldn't have images that big. If you need to worry about managing big images, you're doing it wrong.
You should quit the company. and go somewhere else. Yeah, I mean, usually big images are either because one of the two reasons. First, because people do not really understand what should be in the image and what shouldn't. Very often people would just translate everything they had before, from the every tiny detail, including operating system, into an image, and it becomes huge and massive and stuff like that. No, don't do that. Second is that people sometimes pack into images things that shouldn't be in the image, like WebLogic server, right? Don't do that either.
Yeah.
There are things that, I mean, everything can run in a container, but then for some things it's just a waste of effort, right? And the images are huge. And now people are going to throw stones at me. .NET, I'm not much into .NET, but .NET is massive, especially if you run the Windows-based images, kind of.
Oh, yeah.
Go somewhere else. Learn Rust.
I feel like you should be used to people throwing stones at you by now. Good at ducking.
I am. I'm just letting you know that it's allowed, rather than complaining about it.
Talha says people love Harbor after Docker Hub purged them.
Yes, and so I think that Harbor is not really competing with Docker Hub-like solutions, because Harbor is self-managed, right? It's when you want to manage yourself something. I see Google Container Registry or ECR in AWS, or the same thing in Azure, as a competition of Docker Hub, right? Because kind of, to me, it's apples and oranges, SaaS versus self-managed.
That makes a lot of sense. And then from Talha, also, we had, I wish Harbor had retention cycles. Harbor does have retention cycles.
Yeah,
yes.
Yeah, that was added. I don't remember when, but that was added, yeah.
Yeah, so you can define an image retention policy, and it will automatically put garbage collection on anything that's too old. And we have a question. Can you delete images from Harbor?
Yes.
I think in the past. Okay, there you go. Flat, yes. Love it. All right. So with that, I think we're ready. The image, do you want to, we could gong like before we see the choice. Do you want to gong?
No.
Okay.
No. If it's not real, kind of, I don't want to do it.
What? I mean, we're the one we control the reality of this. This is our universe. We can make anything real that we want to be real.
No, there is no reality.
What you mean is if it's not your idea.
Exactly. It's overrated automatically.
All right. So the what y'all chose from that was Harbor. So let's implement Harbor now.
Okay, so repo, here we have all the choices, descriptions, etc. Harbor, there we go. This is the image I built previously. I have it. Oh, I didn't. Oh, yes. I knew that I missed something. There is a setup. In most of the gists, there is a setup phase. I'm just going to copy and paste that. I'm going to execute a script. This is new. I did it last night, literally. A script that will do the setup, install things, whatever is needed. You can check the script and then wait for it. This will take approximately 20 seconds now for Harbor to be up and running in my cluster. This is just a time for another Whitney jokes. But this time, let me know when it's finished.
Why do girls wear makeup and perfume?
I don't know.
Because they're ugly and they stink. And that's the end of the
now
joke.
I feel that now I feel that if I start laughing, you're leading me.
It's funny because it's not true. It's like, it is kind of ridiculous. Why do, like, women are beautiful and they smell great naturally. Why do they need makeup and perfume anyway?
You want to say they smell great and men stink.
You're putting so many words in my mouth all over the place. Right? It's a tough crowd. I'm going to run out of jokes soon. I'll have to start prepping.
Yeah.
I have a past life. Years ago, I was a professional wedding photographer. Oh, you're complete. No, installing. And I would tell these jokes as part of photographing people, because even when people laugh politely, it still translated to a good smile on camera.
Okay. That's the background story.
That's the background story
Okay.
of the jokes I have handy. I have a couple more.
There we go. I installed the Harbor. I set up everything, whatever was required, and I logged into Harbor. So my Docker client right now can communicate with it. So I'm going to tag the, sorry, that's not what I wanted. I'm going to tag the image, cncf demo,
That's
whatever the
CNCD.
tag was. And I'm going to do that because the image names need to be prefixed with the address of the registry. CNCD, not CNCD. CNCF, there we go. And I tend to always push the specific tag and latest, so I'm going to tag that as well. And then Docker image push. Whatever is the address of the image, whatever is the tag. Okay, wrong one. Oh, I messed it up completely. Look at it, it's pushing something. Nobody knows what's it pushing.
Exciting.
Will it push soon?
It's a mystery.
It's okay.
It converted to an adventure show to a mystery show.
Exactly. I thought I had a typo there. It will happen. There we go. Let's push it now for real. And I'm gonna copy the latest as well, push that one as well. And if I open Harbor here in my browser, you should see Harbor 1, 2, 3, 4, 5.
We make it bigger.
Yes, I can. There we go.
Thank you.
There we go. Library, CNCF demo, one artifact, and let's make this like this, right? And you can see that I have two tags, 001 and latest. I did not install signatures with cosine or whatever else you want to do. Didn't set up scanning vulnerabilities. That will come later when we talk about security. But for now, I have my tags.
And you can see from the date that it's pushed right now. And it's not smoke and mirrors. It's real. It really just happened.
Yeah, exactly. And this time it's not AM.
Nice.
And that's it. That's Harbor.
So with
the image is there.
So with the script, you actually, it looked like you set up the whole cluster, the demo cluster with that script, and then installed Harbor and
no. So I set up the demo cluster earlier before we started the show. There are instructions for that as well, and you can choose between AWS, Google Cloud, Azure, or anything else.
Nice.
And then here, basically, I can show you the script. Actually, the script is just setting up things like, hey, replace couple of values depending on what you have in some YAML for Harbor, like what is the domain.
Certificate, yeah.
Install with Helm, apply certificate, and finally logging into Harbor from the CLI.
Excellent.
That was the setup.
Cool. All right, so we made a container image and we pushed it now to Harbor. So the next thing we need to do is configure our image.
Exactly.
So we talked about, generally speaking about configuration, we talked about how complex it can be. And for me as a newer learner, it's good to say configuring an app or defining an app are two ways of kind of saying the same thing, I think. So we're talking about app definition technologies. And so briefly, we talked about Customize, Helm, Carvel YTT, and CDKs as options to be able to customize your application. So when you're defining all that configuration, you need to worry about a lot of things. You need to worry about like your image, how to tag your image, and how to update your image when it inevitably changes a lot. And then we need to think about all the Kubernetes objects you're going to deal with. You need to think about all the application-specific configuration you're about to make, and then also all of the infrastructure-specific configuration that needs to be associated with this application, in addition to all the other dependencies that are associated with your application. So as you can imagine, with all of these considerations, it gets to be quite a complex beast as your application grows and becomes more complex.
Exactly.
So how are we going to manage this? First, we talked about Customize, which is pretty cool. It's natively built into kubectl, and it also is a standalone Go library, a standalone binary. And Yeah. Anyway, and so it is good for if you want to make more simple changes to your application. You can store, you define where your base files are, and like group them together with configuration with a customization file, and then you can make patches, which are little files that you can change certain things that will be different depending on which environment you're deploying it to. So the problem it's fixing is when you had very long, complex configuration and you only needed to modify small things to be able to deploy that configuration to different environments. So now you don't have to replicate all that configuration every time. You're only defining the little parts that are going to change. And then you can add, oh, sorry.
No, essentially what I want to say is that what makes Customize different from many other solutions is that there is no templating really. So it's always pure YAML. And you just say, okay, overwrite this YAML with that YAML in a way, batch.
Like the number of replicas, depending on whether it's development versus production, is going to be very different. Yeah. Or this connect on this port to this database, depending on whichever thing. So yeah, and then you can just run apply, like kubectl apply -k and point it to the customization file or the directory, and then you did it. Bam. So that's Customize. And purely YAML is a great point. And then we talked about Helm next, and Helm is ubiquitous, and we use the words de facto, the de facto standard for dividing applications in Kubernetes. And it even calls itself a package manager for Kubernetes. And where Helm shines is really for consuming third-party applications. Those are going to be packaged up and given to you probably as a Helm chart as the most common way. And so Helm uses templating, which you just talked about. Templating is when values are, for the values that are likely to change in an application, there's a placeholder put in there. And then that placeholder you define a values file alongside your application. And then Helm also, you can incorporate logic with partials that are called, but that's part of a template too. It could have some sprig function logic in there. Yeah, so Helm is, you could also, of course, define your own application in Helm too, and that's common enough. But really, it's definitely for consuming third-party applications. Is there something else you want to say about Helm? Well, wait, you're muted. You're muted.
When people say that it's de facto standard, I might agree or disagree with that. But if I become a bit slightly more precise, it is, in my head, almost certainly de facto standard for the third-party applications. Whatever you need is available as a Helm chart, like Postgres or Kafka or whatever you want, right? So I'm kind of limiting the de facto standard to third-party applications.
Yeah, I like that. We have a question. What's the point of JSONnet that well-known projects use?
For people who like JSON.
Yeah.
Some people freak out when they see YAML or templating, like in case of Helm, Go templating. So it's a different way. It kind of reminds me, it's almost like a combination of Customize and Helm, but all based on JSON.
Oh, speaking of a combination of Customize and Helm, that leads us to our next tool, which is Carvel YTT. Bam, that was you just made up for screwing up the last transition with that.
There we go.
Yeah. Carvel YTT, it does patching and overlays like Customize, and it does templating like Helm. And the way it does templating is with Starlark, and it keeps it all within YAML. So you add your logic and templating with YAML comments. So it is YAML in, YAML out, YAML all the way through, which can be great for validating. And it's also cool because it's YAML aware. So it's working with YAML structures. So you don't have to worry about indenting or spacing or any of the little typo gotchas that can happen with pure vanilla YAML.
To me, that's the major difference, that YTT is really a way how to accomplish things based on YAML, right? While Helm is a free text templating, really. Just happens to most people write YAML, right? But it equally applies to anything. You can write HTML or whatever you want, which has certain advantages, but also disadvantage in terms that it's not really aware of YAML itself, right? Whichever mistake you make, you will not find out. I mean, you will find out ultimately.
Yeah, so I think that maybe wraps up Carvel YTT. Is there something else we should say about it in terms of its features? It's a powerful all-in-one YAML templating tool. That's what the YTT stands for, YAML templating tool.
Exactly.
Yeah.
I didn't know that until now.
You said that
Honestly.
last episode.
Did I?
Yeah. You said that
Okay,
last.
so I will forget by the next episode again.
It's great.
So when I say that I did not know that, that does not necessarily mean that I never knew it. That's what being old means.
It's all right. I'll tell you like it's new again next time. It feels nice to tell you like it's new. So this is great. Talha says they freak out. I think they freak out over JSON or too much YAML.
I don't know. It will be put additional info.
All right, and then finally we have CDKs. And so CDKs is a way to write configuration in the language that you're comfortable with and within your IDE. So CDKs offers a more simplified, so you consume CDKs just like a regular code library, and then it also offers a more simplified interface for dealing with Kubernetes objects. Some of those fields can be abstracted away from the developer who is customizing their application. So it offers a simpler developer experience because you can harness the power of code, and then you also have the simplified abstractions, and you're just working with tools you're already comfortable with. And then you also, when you're ready for all that to become YAML, you run the synth command, and it is outputted all. So you do get pure YAML in the end that can be applied to any Kubernetes cluster. From ops perspective, you can put opinions into your CDKs library that gets distributed, and you can also run policy as part of doing that synth command. So you have some control there. Yeah.
One thing that I particularly like about CDKs is that since it's code, you have autocomplete. Now, with baked in, whatever is baked into Kubernetes as well. But now comes the interesting thing, to me at least personally, right? You can create new libraries on the fly based on CRDs in your cluster. You can go to your cluster and say, there is a CRD X, whatever it is. Create a library, and from there on, I have autocomplete, not only for objects baked into Kubernetes, but for custom resource definitions.
That's cool. It does that by consuming the JSON schema, and then it can.
Yeah, you essentially you download the schema of that resource, and then you tell CDKs, here's the schema, do something about it.
Yeah, make it into an object that I can do something with. Yeah, so CDKs is super cool. And y'all chose from those choices. You chose Carvel YTT. And that ended up being a big choice because now we're going to see Carvel YTT all the way through to the end, to the bitter end, right? We're carrying this decision through to future chapters.
Yes, next couple of years.
Yeah, Carvel YTT is now a big part of all of our lives. So here we are. Show us how it's done.
Yep. Did you share my screen?
Yes, I did.
Okay, so there we go. Define the application. Just continuing down the repository. We set Carvel, there we go. And I have a setup script here. There we go. And then let me show you a couple of files, right? First, deployment YAML, right? So it is YAML for big part, normal one. And then we have those instructions that say, hey, the value, and this is the difference between YTT and Helm, right? It's not freestyle templating. I'm templating values really and saying, here, the value should be whatever is defined as name, right? And somewhere else says image repository and so on and so forth, right? And some funky stuff because this manifests need to serve all the possible permutations of all the choices. So there are some conditionals and things like that. Anyways, that's a deployment. I have a standard service which is templated as well, mostly with names because everything else, none of the other things change. And finally, ingress that also has a couple of values templated. I'm not doing anything really special. Now,
So that that templating, those values are in YAML comments, and that's a language called Starlark. That's a Pythonic dialect. And you can use it to write functions, or you could use it, like, for example, Scott, when he was on, Scott Rosenberg showed us using it to validate schema, and that was cool. Oh. Mm-hmm.
Yeah, exactly. And then we have schema, which is in a way equivalent to the default values file in Helm that contains all the values, the default ones, right? So if I don't say otherwise, they will be used as is, or I can overwrite them in a separate file, which I did here, which right now it's empty. There is nothing, you see, empty. Now what I'm going to do is add image tag of the image that I built earlier, and then if I output the file again, so I'm going to use the default values for everything except image and tag, which is going to be 001. And then I'm going to do this. I'm going to say, YTT, use that schema, and then use everything in the directory resources, which is where all my manifests are, and overwrite the default values with whatever is defined in values dev. And once you process all that, I want you to output the outcome into app YAML file. There we go. And now I got pure YAML, right? This is the deployment and ingress and service with exact values I want. So all I have to do is kubectl, namespace is dev. I want to apply whatever is defined in YAML dev. Let's go. And I have my application created, applied. And if I open this address, this is how I configured my ingress in a browser. It should be running. There we go. This is a silly demo. This is a very advanced application. Don't judge. And
all right.
That's about it.
Amazing. We do have a question. Is YTT created by Google? It's a...
I don't think it is. I'm not sure. No, YTT was started as a Carvel project that I believe was the project or company by itself, and then it was acquired by VMware. I might be wrong here. I don't know the names of people who started, but I don't think it's Google. Maybe folks from Google, kind of, expats. That might be.
It's. I know VMware cares about it deeply. Yeah.
Should, because it's a cool project.
It really is. So after we did that, then now we need to, our application's running in our cluster, but now we need to receive traffic that is secure. So we talked about use HTTPS. And that was an episode where we had only one guest, and that was Ashley Davis, who taught us about Cert Manager. So Cert Manager is very easy to consume. It's like you just say, I want a certificate for this domain name, and I want to use this issuer, which is connected to a certificate authority. And then, and I want it to go into this secret, and then it just makes a certificate for you and puts it in that secret, and it will auto renew that certificate, so you don't have to think about it ever again. That's what the user experience is like.
Yeah, it's one of those things that runs in the background and does the magic. You don't even know about it. It just puts certificates everywhere.
Excellent. And I think that's all we need to say about that.
Yeah.
Yeah. So
should we do a demo?
Demo time? Yeah.
Yeah. Ready? Okay.
Yes, you're on the screen.
So, HTTPS, all the information. Again, we always start with all the information in choices. Only one choice, Cert Manager. By the way, choices in most cases are limited to cncf, right? So it's not that those are the only choices to do something, but all the choices within cncf, let's get. Anyways, if I go to Carvel YTT, here we go, and I have ingress. Now, ingress here, the important part is that it has a label, Cert Manager Cluster Issuer Production. Now, that label by default is disabled because the value TLS enabled is set to false by default, right? So I'm going to enable it now by changing the value of TLS enabled. And the second file, the new one, is the certificate YAML that basically tells cert manager what is the certificate that should create, and most importantly, what is the host, the domain or DNS that should be associated with that certificate, right? And then that certificate will be injected into the ingress that I showed previously. So, and finally, there is schema with the file that says somewhere, if I find it, there we go, right? This is TLS enabled by default false, so I'm not using TLS, I'm not using Let's Encrypt, but I will do it now. And I will do it by changing the value TLS enabled to true in the schema YAML. And then I'm going to execute YTT just as before. This is the same command as before to generate new app YAML. And now I can do kubectl namespace dev. I want to apply whatever is defined in YAML dev. There we go. And you can see that certificate was created, didn't exist before. And ingress was reconfigured, updated, right? As a result of creating that certificate, we are going to get those resources here. There we go. Certificate request, that's essentially the process that is going, in my case, to Let's Encrypt, but it could be others, to request a certificate.
And that's created by cert manager. That's not something that a human creates. Mm-hmm.
All that. The only thing I created is really certificate itself, and that's CRD with controllers in Kubernetes when you install cert manager that spins up additional resources. And the second one is certificate itself. It's not yet ready. The order of that certificate, and finally secret. This is where the certificate itself will be stored. And if I refresh that, it should be done, right? Now it is approved. I got the certificate, the order is valid, and finally I have a secret with 2 entries right now, right? So if I go back to application, now what I didn't show really previously is that my application, actually let me show it here. There we go. Somehow, why does this doesn't work? There we go. This, what I ran before application, right? No certificate here. It's not secured. It's HTTP without TES. Now, if I tried HTTPS, it wouldn't work. Now, if I change to HTTPS, there we go. It's still the same application, but this time with HTTPS, it's secured. It has TLS. It has certificate. It's safe, right? Nobody will be spying on you. At least not as much as before.
No one's spying on our silly demo.
Exactly.
It's protected. Thank goodness. Phew. Yeah, Cert Manager is wonderful because it's so easy. And I think the magic can be forgotten because we just take it for granted. So it's cool to learn about. So then we decided we want to add a Postgres database to our application. And so we talked about 2 technologies for that, but we had 3 choices in the episode. So the 2 technologies to add a database to our development environments were Helm or Crossplane. And then with using Crossplane, we had 2 choices. You could use Crossplane to install that Postgres database with actually was going to be done using Helm, or you can use Crossplane to install a cloud-based database. So those were our choices. And
exactly.
Yeah. Mm-hmm. So Andrew Block came on and talked about Helm, and I'm not sure what we want to say about Helm that we didn't already say in this episode about Helm. It's great for third-party apps, which is exactly the use case we're describing here. So then the question becomes, well, why would we want to add in Crossplane at this point? And so Dan Mangum came on, and his argument was that with Crossplane, you can enable tomorrow's evolution without introducing complexity now. So that meaning you can make it okay, let's say what Crossplane is. Crossplane can make any API interact with Kubernetes. You can interact with it through Kubernetes. And so that's cool because you can use all of the Kubernetes ecosystem tools. You can use the handy dandy Kubernetes control loop to watch resources. And then also with Crossplane, you might have very complex configuration, but you can create a claim or a very simple resource that your developer sees with only the bare minimum of the knobs that need to be configured. And then what you have implementing that thing behind the scenes is something that ops people can work on that's invisible to the developer. So Dan's argument is that you can have this simple interface for the developer, and then you can have that Postgres Helm chart easy local database implemented behind the scenes. And then later, when you're ready to upgrade to cloud, you can add that change to that implementation, but the developer interface can remain more or less exactly the same and very easy to use. So that's how you would enable tomorrow's evolution without introducing complexity today. What do you think, Crossplane man? Yeah.
I mean, I'm biased. I work with Crossplane, so.
Oh, well, I mean, you don't need to. This is exactly the time when you would show your opinions or talk about it.
Yeah, I mean, it's awesome. Kind of. I wouldn't be working with Crossplane if I wouldn't think it's awesome. Absolutely.
In this particular use case, is there something else you want to say about Crossplane that I didn't, or clarify about what I said?
You know, instead of explaining how what it does and how it works, I would simplify it even more and say, whatever are the reasons for which somebody would use Kubernetes for applications running as containers, those same reasons apply to anything else, right? Same benefits. Whatever those benefits are, you know, people use Kubernetes for some reason or another. Somebody might say, because I have an API. Excellent. You have an API. Drift detection. Excellent. Reconciliation, and so on and so forth.
What about cost optimization?
Cost optimization, yeah, that's coming. That's coming.
Okay.
I cannot talk about it yet.
Okay. Awesome. So you would use Crossplane for any reason that you would use Kubernetes. If you like Kubernetes, you by default probably like Crossplane.
Exactly. And if you don't like Kubernetes, there's something wrong with you.
Crossplane also is pretty great for a GitOps story too, because of that control loop. It can you can be watching resources that are completely outside of your Kubernetes cluster, and with that control loop, like in tandem with Argo CD or Flux or Cap Controller, you can use a Git repository to define it, and then make sure that your third-party resources, not even your Kubernetes-based resources, your completely external resources, can stay in the state that you define in your Git repo.
That's essentially, probably from my perspective, one of the biggest, if not the biggest advantage, that you can leverage the ecosystem, right? You don't need to do something completely different for infrastructure than for applications, then for this, then for that. Simply it's the same ecosystem. You like GitOps, use it. You like monitoring observability with this tool or that, use it. Simply it works with anything that works in Kubernetes, which makes it very ecosystem friendly. Yeah.
So, for example, the Carvel YTT that we're excited to use to define our configuration, we'll use that to define Crossplane resources.
Exactly.
Which the winning choice of the three is that y'all chose to use Crossplane to create a Cloud SQL database, and so that's what we're going to implement right now.
Yeah.
We're going to acknowledge a comment. Yes.
There is a comment. Yeah, let's go for it.
Yeah, let's acknowledge our comment. I'm biased to my crunchy data PGO customized manifests and Helm charts. So it's a tried and true solution, right? Yeah. I don't know what crunchy data means. What does crunchy data mean?
I'm not sure. I'm guessing that it's self-made manifested for PostgreSDB. I'm guessing.
And We should say, and this is actually a very popular solution. So you use Helm, you change the values and things that are already templated, but then when you inevitably want to change values of something that's not already templated, then you use Customize to overlay to patch those values.
Exactly.
So you're not actually changing the Helm package itself. Excellent. All right, so let's implement Crossplane.
Yeah, put my screen on.
Yep.
Okay, so continuing down the rabbit hole,
There we go.
this is all the options for databases and so on and so forth. Additional material, and there we go, right? Helm chart, crossplane composition in Kubernetes or in cloud. You chose cloud. And that means that I will run the setup script here, which will, this one is now going to install crossplane. And then it's going to install some of the providers, not all. The
What
rest
is a
is
provider,
coming soon.
Victor?
Okay, so provider is when you work with crossplane, you work with providers, meaning that when you install a provider, you install custom resource definitions and the controllers that match one-to-one something on the other end. So, for example, if you install a provider for AWS, AWS has close to 1,000 endpoints, like EC2, VPC, subnet, and so on and so forth. And then you get the same number of CRDs in Kubernetes with a matching controller that you can just use to create custom resources yourself. It's like, hey, I want to define EC2 instance, right? So a provider is a collection of resources that match real resources on the other end.
Excellent.
And one thing that Whitney didn't tell you, that's that we had a second choice. That's whether if it's going to be cloud, whether it's going to be Google or AWS or Azure. You chose AWS.
Barely,
So
by
we're-
one vote. It was the closest one. Real nail biter.
Oh yeah, exactly,
Yeah.
exactly. And now I need to get my credentials, which I didn't get. I think there we go. Don't look. Here are my credentials. You cannot see them, anyways. There we go. AWS credentials. I'm going to export a variable that says this is going to be running in AWS. I'm going to run a setup script. Sorry, I'm going to make it executable. And now I'm going to run a setup script. Now, this setup script is going to take approximately 2 jokes time.
Oh no.
Because now it is installing the AWS, here we go. It installed AWS official provider, which means around close to 1,000 custom resources. And it will take approximately 20 seconds, maybe half a minute until all that reconciles.
As
so,
a consumer, what if I just want to use the Amazon RDS database? Do I have to install all of these, like 872, I think is custom resources, just to use the one?
Today, yes. Tomorrow, no, because we are about to release, to break providers into smaller groups. But that's a work in progress. So you will need to wait for a bit more time. I'm reluctant to say whether it's going to be days or weeks, but it's coming very, very soon.
This is a question of just like trying to understanding controllers a little better, custom resources a little better. But with these 872 resources, are they actually running workloads, or are they just like definitions that won't be running until they're implemented?
So there are 1,000 approximately custom resource definitions for AWS. But then there is only one controller. So one physical pod running that is actually doing something for AWS. So if I do this, get CRDs and grep AWS, and then let's say VC to count how many lines we have, there is 600 actually. I'm using one of the older versions of provider. Now there is more than 600, right? But if you go to n crossplane system, system get pods, all those 603 CRDs. What did I do? No resources.
Crossplane has 2 S's.
Yes, there we go. There is only one physical controller. Where is it? Here we go, for AWS. So you get one pod per provider.
So everything we're not using that's not the database is just basically a text file in the system. It's not using really any resources.
No, not really. It's using some because Kubernetes itself needs to do certain work to acknowledge and accept any extension of its API, which is CRDs.
That makes sense.
So depending on which cluster you're using, the control plane itself might use slightly more memory because of that, but outside of that, it's all good.
Okay. So it sounds a little worse than I think it actually is.
Yeah, it's not bad, and it's going to get even much better. So here we go. I have, since we chose YTT, we have a definition. Basically, what I'm defining here is saying I want to create something called SQL claim. Now, SQL claim does not exist. You don't get it by installing Crossplane or AWS provider. It's an interface that I created, right? So we call it Crossplane composition. I created a new definition that says whenever somebody wants to manage database, you just define SQL claim and you're good to go. And then I'm going to replace a couple of values here. There we go. 1, 2. I'm just enabling Crossplane as a value. And that's about it. And I'm going to generate the file just as I did before with YTT. Same command. Now, what we got now is this thing. SQL claim. Now, what is going to happen behind the scenes is going to be huge. But from developer perspective, all I did was saying, I want something called SQL claim. These are the labels that will tell you where I want to run the database. It could be somewhere else, and some parameters. It's interface agreed between me and developers. So I apply this. Come on. Patience is a virtue.
So the word claim, you made the resource SQL claim, but calling that resource a claim is just a convention that is common in. You could call it SQL interface. You don't have to use the word claim.
You could call it something. Literally. The name is whatever you want it to be. Literally. And the schema is whatever you want it to be. Exactly. Dog with no legs. There we go. And we got SQL claim, which is not yet ready. Now, this will take approximately, I believe, 5 to 10 minutes until we create everything in AWS. Which is a long time. So I suggest we go to the next section, and then before we start the demo of the next section, I will come back to it and it will be ready, the database in AWS.
What the point I was trying to make about the word claim is that if you're someone who works with Crossplane and you're talking to someone else who works with Crossplane and you're talking the same language, you're trying to reference the interface, the simplified interface you made for developers at your particular company, you would call it a claim, and they would understand when you call it a claim what you mean.
So essentially, when
with
you
your
create,
mouth.
when you create those new compositions, new interfaces, which is whatever you want, you're designing what that interface will be. You get two things. You get what we call a composition and a claim. Now, the difference between them is that composition is a cluster level resource, right? And claim is a namespace level resource. And you usually, for security reasons, you don't want to allow people to create something on a cluster level because then it's hard to secure and so on and so forth. So you would use claims, what we call claims. But it's just the name really from the developer perspective is whatever you want to call it. Just don't call it Victor.
Or especially now, call it Victor. Okay, so we're going to go on and we'll check back on our Crossplane created database shortly. So what we are doing next is we're going to manage the schema of our database. And so we had two technologies come on and talk about themselves for that. And one is Liquibase and the other is Schema Hero. Schema Hero is a Kubernetes operator that allows you to define the schema of your application, declaratively and in a language agnostic way. What else should be said about that? That feels like the long and the short of it. It can show you the changes that it's going to make when it reconciles the schema that you've defined with the schema that's there. So you can define a new schema, define the changes, it'll show them to you. You can run policy on those changes and then actually commit those changes.
From my perspective, what makes Schema Hero different is that, it is managing Schema Hero declaratively. Other tools do it or don't. What makes it really different or special is that it is using Kubernetes resources to do that, right? So you are doing it Kubernetes way. You can do GitOps. You can do whatever funky stuff you do in Kubernetes, you can do with Schema Hero, right? So to me, that's, in my head, that's the major differentiation rather than the features. Because really features seen in Schema Hero are seen outside of Schema Hero as well. What makes it special is that it is Kubernetes native, let's say.
Nice. Great. And so then we had Liquibase, which is not specific to Kubernetes. And it sometimes when you're working with more sensitive data, it isn't okay to just say, here, I want this state to be. Like, you need to have control over the steps that your data takes to reach the desired state. And so it has more of a change log interface where you can work with how the data is changing to get it to where you need it to be. Is that... Oh,
yeah. That's Liquibase is a veteran in the industry. It's been there for a long time. I used it myself heavily, like a while ago. Still use it sometimes. So it's in a way, Liquibase is probably the main tool that advanced how we manage database schemas, right? It's changed the industry in a way.
Yeah, cool. All right, and then y'all chose Schema Hero for that one, and which is a good thing because Liquibase was a red herring, they say. It was a false end. It's not a CNCF project, so even if you picked it, we weren't going to implement it. So here we are. Let's implement Schema Hero. You ready?
Yeah, let's do it. I need to switch my screens. There we go. When I say I'm ready, no, I'm waiting for the database yet.
Still waiting. We blew through that too quickly.
Yeah, that's okay.
Talha has a comment.
Okay,
the problem with Liquibase I have encountered 3 years ago, devs creating non-independent SQL and multiple schema files.
Yes, so it's not really... I believe that you can use Liquibase in both declarative and imperative way, but really it's designed to be imperative. So if you know what you're doing, you can do things that you cannot do with declarative tools for managing schema. But on the other hand, if you mess it up, it's easier to mess up, let's say, but also provides more freedom. I think that it's not necessarily very developer friendly because you need to know what you're doing. I see it more like DBA oriented, tool for DBA oriented people.
What's DBA stand for?
Database administrator.
Okay.
Yeah, people who dedicate their lives to databases.
Talha says Rails developers love it. Migrate up and down until they drop the table.
And while we were talking, I got almost, right? So route tables were created in AWS, subnets were created, VPC was created, all the things you don't care about if you're a developer, and so on and so forth. The only thing missing is that instance is still being created. But I'm going to bite the bullet here and assume that it's going to be done very, very soon, and then jump straight to what's
so
next.
Even though none of those things, we didn't see any of those things in our YAML that we interfaced with to create this database, it's all getting made behind the scenes by
so the person who designed compositions designed two things. Essentially, this is the interface. This is how you define database. Don't worry, and it contains only the things you care about. And behind the scenes, if you select through labels to be AWS, it will be all those things. And if it would be somewhere else, like Azure, it would be something completely different. But for you as a user, the interface is always the same. If I just change one label, I would get the database somewhere else, including maybe in the same cluster. but the implementation would be completely different. So it takes a bit of time to grasp completely compositions. So I'm not sure whether we would have time to go deeper here.
Yeah.
But there are videos on this channel. You can check them out. And while waiting, let's see whether the database instance was created. Still, AWS, you're slow today. 7 minutes already, and you're still not there. It will get there probably, eventually. And until it gets there, I'm going to do this. I'm going to show the database. So, user would not care about all those resources I showed. From the user perspective, all you care is that, hey, I have SQL claim because somebody put it like that to be called. It could be called something else. It is not yet ready. When it becomes ready, let me know. And I will just run this. This is a kubectl command that says, hey, wait until condition is ready for something called SQL claim with this name within 15 minutes. So we're going to get the output soon. And until then, Whitney, you know what comes now?
We're going to talk about
another joke.
Another.
I know.
Why can't dinosaurs talk? Because they're all dead. Because they're.
I'm trying to go through all the emotions possible through your jokes. I had hysterical laughter delayed in the first one. The second one was kind of, hey, girls, you cannot speak like that. And now it's, oh, poor dinosaurs. The only emotion I'm missing right now is crying. I promise I'll be crying on the next show. Doesn't matter what it is.
We gotta, but I guess you need like a snare and a cymbal in addition to your gong for joke time. Oh goodness. Do you want to start talking about develop an app?
Yeah,
because we'll get there.
Let's talk about that, and then we'll go through the demo of all of those kind of fast, because the rest is going to be faster.
Okay. So
blame AWS, not me. If people chose Google Cloud, it will be significantly faster.
And now we're stuck with AWS through to the end. So thanks for that one vote. So develop the app. So we have 4 choices for that. And this is our final choice that we made before today. So this was just last week. We talked about developing the application. The choices we have were telepresence, dev space, dev file, and localhost, which Victor represented localhost because no one from there showed up.
Was it successful?
No, I still have no idea what
I
it
didn't think
does.
so. Okay, cool.
Well, I guess let's start with localhost. Localhost makes it sounds like you have a UI to be able to develop through. So it's really for developers who are CLI adverse. And does it make Kubernetes invisible completely?
Yeah, I mean, you still need to know something about Kubernetes, but it's mostly, going through Visual Studio Code, just as, there are, generally speaking, 2 types of people who would do things from terminal, people who would do things from Visual Studio Code or JetBrains. And when I say things, I mean, I'm ignoring Kubernetes, right?
What about the people who open a terminal in their IDE? Which camp are they in?
That's me. Yeah. No, that still counts as terminal people.
Okay.
Because so let's say that you're building an application, right? Ignore containers, ignore everything else. So let's say that you're using Java with Gradle to say something, right? Some people prefer clicking a button in VS Code. Some people prefer executing Gradle this and that, or Maven, or whatever you're using. Now, for people who prefer doing it with a button in Visual Studio Code, localhost gives them ways to deploy their application and synchronize the code from your laptop to that application in a Kubernetes cluster, local or remote, by using Visual Studio Code without the terminal part in it.
Okay, nice. Can it do like hot reloading? Can I see my changes immediately when I make them? Cool.
Yes. Near real time. So it
Near
means
real
it's
time.
never immediate, but it's
Yeah.
close to it, yes.
Spoken like a true tech person. Okay, so does it have a declarative way for me to define my development environment, or
No, it's clicking buttons.
can I interact
There
with
is
other
actually
services
so
running?
there is a file that is generated, or the file that you can use write yourself, and you can actually accomplish the same things with localhost CLI. So you can declaratively define yourself from the start and so on and so forth. But I'm ignoring that part because it's much more focused, obviously, on
The developer
doing
experience.
that through a UI.
Click, click, click.
Click, click, click.
Yeah.
Select. Click, click.
Can I easily interact with all the other services running in my cluster?
I
With
mean,
localhost?
those. It's not really designed to interact with all the services you have in a cluster. It's more focused towards this is the application I want to run in a development mode in my cluster.
What about our use case where we'll have our application in the in our cluster and then a cloud database? Can I access my actual cloud database when I'm developing?
If I would be deploying it with localhost, yes.
Okay.
So let's say that everything that I will show later for the choice, which I'm not going to name, I don't want to give the honor away. Think of it as doing the same, but through the UI instead of as I'm going to do through CLI.
Okay.
It's not exactly the same features, but the same direction.
Okay. So that was the synopsis for localhost. So it's very UI based and click, click, click for developers. That's their tagline. We gave it to them. And then we also talked about dev file, which isn't an actual implementation. It is a specification for a way to define a development environment that is used by many tools, none of which that I can name right now. But it does seem to be something that AWS and Red Hat are both behind. So their particular tools use it. And I'm actually, oh yeah.
Yeah, it's a specification, right? More than anything else. No specific implementation, just that you have specification for open application model, which is just a spec. And then implementation would be kubevela. Or open telemetry, and then implementation would be one out of several dozen tools that actually say, okay, I'm going to conform to this specification.
It's good that it's declarative, and it's good. Its specifications are good to avoid vendor lock-in and promote collaboration. And I'm going to do an enlightening episode on Friday about dev file if you're more interested. And I'll know a lot more after Friday.
Okay.
So tune in for that. And so those are the first two. And then we also talked about telepresence and dev space, which I would say are the two most popular in this sphere. Telepresence, with telepresence, you can open a tunnel to your cluster, and you can actually, the real traffic that's meant to hit your application in the cluster gets redirected to your laptop. So you're dealing with the real traffic, and you're also able to interact with all the other services in your cluster as though your laptop is in the cluster.
Yeah. So imagine that you're developing a backend application, but for that backend application to work correctly, you might need a frontend and a database, right? And then let's say, for the sake of argument, that you don't want to deploy all three of them to your dev environment, right? You just want to deploy the backend application. Now, what you would do with telepresence is instruct that backend that it can go to the database running somewhere else in staging environment as if it's local to the application itself. So that would be one direction, right? From your application to the database. And then there is the other direction saying, hey, I want this I don't want to go to the frontend because I'm backend, but I want this frontend running somewhere completely else, not to go to the backend that it normally goes, but based on special query or request or something like that, go to my laptop or wherever my backend application while I'm developing is running. So it does that type of tunneling. Now, there are other features it does. Some overlapping with the next choice, but that's the main feature, I would say.
Yes, that you're able to interact with real traffic. We have a question. What tools exist for that type of redirect traffic to a local app?
Telepresence.
Telepresence. Yeah, it's
Yeah.
the one. Yeah, if you want to deal with real traffic, if you're trying to debug locally, they use the word remocal because you're interacting with remote resources, but with a local experience using your local tools and IDE and such. Yeah, and so then we have DevSpace, and DevSpace has kind of, it sounds like a similar user experience to telepresence in that you can develop on Kubernetes, but using all of your local tools. But
I wouldn't
I
say
see
it's
you.
similar. I mean, there are some
Okay.
overlapping things, but I think telepresence is primarily concerned with how something you develop communicates with something running somewhere else.
Yeah.
This is more like how you develop.
Okay. And it does have a declarative specification. You have your what's it called? DevSpace YAML. And then also with telepresence, you have to have a client running on your cluster to be able to make it work. And with DevSpace, you don't need a client on the cluster. It's doing everything through the kubeconfig, through kubecontext file.
Exactly.
But so you've defined what you want your develop environment to be in a DevSpace YAML, and then you run the command DevSpace dev, and then it will look for those resources. If those resources don't exist, it will create those resources. If they do exist, they'll connect you to them. And then after you just run that one command DevSpace dev, you're able to develop your application on Kubernetes.
Exactly. And it will synchronize your code all the time. So you will always have the latest what you're typing there somewhere.
So, hot reloading via file sync. Yep. Anything else we need to say about that? I like that it's declarative.
Yeah, that's it.
Yeah. So the winner is DevSpace. Y'all picked DevSpace.
Yeah. Wait, I have even somewhere. I have a picture. There we go.
Woo! Because
by
this was
huge
just last
margin.
week. Yeah. DevSpace was a big winner. I wonder if that's because you were convinced, or I feel like people come into our polls sometimes, after seeing our show, like having an opinion, but also a lot of people maybe already use one of these tools
Yeah,
and
exactly.
like it and vote for it. Yeah. So
Exactly.
so let's implement developing on DevSpace for the first time.
Oh, and everything before that.
And everything. Oh yes, and everything leading up to that.
Exactly. So can you put my screen on?
You're on.
Okay. So the SQL claim with all the resources, that's ready. So all the AWS and non-AWS, everything required is there. And if I send a request to my application on /videos, this is the special endpoint or path that means that my application should communicate to the database. You can see that it connected to my application, but the application tried to connect to the database and says there is no table videos. Doesn't exist. You never created it, right?
All right.
And that's where schema management tools come in. And we chose Schema Hero. So I'm going to use Schema Hero to set it up, to create the schema now in the database server and the database created in AWS, right? So I'm going to install Schema Hero installed. Then I'm going to go to Carvel YTT variation of it. I'm going to show you. No, I'm going to skip showing the templates and straight into modifying the values, saying Schema Hero enabled. You will see the outcome in a second. I'm going to generate the app YAML file, just as before, same command always. And what I got now are two things. Let's go to the first one here, first database, right? So this is now Schema Hero. It says, hey, this is how you connect to your database. And in my specific case, I'm connecting to the database with credentials stored in a Kubernetes secret. And that Kubernetes secret, among other things, was created by Crossplane. So when Crossplane created the database, that composition, among other things, has instructions how to create a secret with authentication to the database. And then, Schema Hero, I'm telling it, hey, I want you to create a Kubernetes resource called table. And that table should be called videos in a database CNCF demo. And it should have those columns, right? So I'm just defining as a Kubernetes resource how my database schema should look like, a simple one in this case. So what I'm going to do is apply the files that I generated with YTT, that this time includes schema hero. Come on, why is my cluster slow? There we go, right? Everything is more or less the same. The major difference here is that I created the database instruction of schema hero, how to connect to it, and a table. And now, if I send a request to the same endpoint as before, I got null. Now it's not complaining. Now it's saying, yeah, I can connect to the table videos,
It's
which
empty.
is a good sign, but it's empty. So I'm going to execute those two requests that will put something in a database. And now, if I do the same, send to videos, you see that I got the output. Okay, these are your entries in the database.
Nice.
And then we want to develop, right? And for that, as you already heard, different choices like telepresence and dev space. And by the way, if you're following through the repo, you don't have to make the same choices. You can make any choice you want. But today I'm going to make a choice of dev space, and I'm going to use Carvel. And I'm going to set it up first. And I'm going to show you dev space YAML, the YAML that you, Whitney, mentioned, right? It's a simple one. It says essentially, hey, there is a pipeline, meaning that whenever you want to develop something, this is what should be executed, right? And this is that same basically YTT instruction. So essentially what I'm saying, hey, use YTT to transform your templates into the end result, YAML itself. I'm skipping parts that are not interesting. What matters is then in deployment section, I'm saying, hey, use kubectl. It could be Helm or something else. In this case, kubectl to apply whatever is in that directory. That's where we are outputting YAML. And finally, this is the label selector, meaning that through those labels, find the application running in a cluster and then modify it, meaning use this image because this has a Go compiler. In my case, I need Go to compile my application. Synchronize whatever is in the current directory to that container. Execute this command when you start, and that's about it, give or take. A few other things.
And
now,
do
yes?
you have to enable hot reloading, or does that just happen?
It just happens.
Okay, cool.
So it's baked in. You might be able to disable it. I haven't tried that, but it's enabled by default. Essentially, or it's not enabled by default, actually, to be more precise. If you specify sync and say synchronize this path, then it gets enabled.
That's where it's
with all the files in the current directory in this specific case.
Gotcha.
So dev space, dev, in a namespace, dev. And now it will take approximately a minute because I have a poor man's cluster, very small. So it will need to create the application that's going to be fast. And you can see actually that it applied the same manifest that I normally applied with kubectl before, right? Schema hero, this and that. Now it is waiting until pod is running. It is running. And it is opening localhost. So from my perspective, it doesn't matter whether this is cluster running on my laptop or in AWS in this case. From the user perspective, it will look like it's working on my laptop. And here we go. I am now inside of that machine. I'm inside of the container that is attached to Kubernetes pod and what's not. And it's running things, and I can do development. So let's say that on my laptop, I would like to run the application with Go run. And this will take like 10 seconds, I think, until it downloads all the libraries the first time only. It's a bit painful. And once it does download all the libraries, you will see it up and running. In the meantime, let me open a second terminal. I will explain in a second why. Where am I here? There we go. I'm going to do something. I'll explain in a second. Vim, let's say, what do I have here? That shell. I want to simulate development, so I'm going to modify some file. Let's say that I'm going to modify root.go. And I'm going to change.
Do you develop from your terminal?
No, not normally.
Simulating
No,
development.
normally no. Sometimes I do. But what I'm going to do is change the message and put a bunch of exclamation marks. I did not save the file yet. I will do that in a second. Now I'm waiting for my initial application to be, or libraries to be downloaded. There we go. It's almost there. And you see that it opened automatically browser tab, and you see this is a silly demo, right?
Yeah.
Now, if I go back to my laptop and I save this change, this is on my laptop, and go back here and rerun go run. It will take a second. There we go. And now, look at that. Right? Normally, I was too lazy. I should have set, in Go, you can set that it hot reloads go run command as well, but I didn't. Anyways, whatever I have on my laptop as a source code is automatically synchronized in my application running in a cluster, which is absolutely awesome.
Amazing.
And
that's chapter
I think
1.
Yeah. And I'm going to exit here, and I'm going to exit again. No, I exited wrong. My God, what did I do? What I'm going to do is say, now I messed up. I can execute dev stage purge to delete everything I did, which I messed up. Now I need to load my credentials again from AWS. I'll do that later. But you can destroy the things. When you're finished, you just say purge, and it will go back to how it was before you were developing.
We have one does not simply exit Vim. That's
exactly.
And Talha says Liquibase is better than Schema Hero in their opinion. So DDL should stay as DDL. What do you think about that?
Personally, Liquibase, so there are two kind of comments or questions, right? Liquibase, from the feature perspective, is better than Schema Hero. I agree with that, right? The things that Liquibase does goes beyond what Schema Hero can do, especially or mainly when you deal with non-standard things, right? If you just create tables and views and things like that, Schema Hero works great. But then if you need something Postgres specific, or maybe transformation of data or migrations of data, not schema, it doesn't. Liquibase has those features that Schema Hero doesn't. Now, what makes Liquibase in my head great is that I can package it all together with the application, right? And I can say, hey, this is my Vitity or Helm or Customize, and it contains everything that application needs, meaning Kubernetes manifests like a deployment, ingress, but also tables. Basically, I can put it all together, which to me, and then apply it with Argo CD or Flux. So going Kubernetes native has a lot of benefits. Now, from the feature perspective, Schema Hero is not as rich as Liquibase, but it has the advantage of being Kubernetes native.
Excellent. Victor, we did it. It's done.
We did it.
We did it.
Yeah.
Chapter 1. Yay. Thanks. Thanks everyone who stuck around with us this whole time. We're going to start chapter 2, which is getting our application from where it is now to a production environment. And we'll start that the Tuesday after KubeCon. So, meanwhile, if you're going to be at KubeCon, Victor and I are giving a talk together. Look, check it out. It'll be something. It'll be memorable, for better or worse. I don't know. But you'll remember it.
We are going to enjoy it. Now, whether the audience is going to enjoy it, that's debatable.
Yeah. Well, yeah. It's going to be fun. We can promise it'll be fun and memorable. Whether it'll be correct, whether we'll teach you something, whether it'll be a hot mess, that's up in the air. It's going to be fun. All right. I'm getting a request for one more joke. Victor knows this joke, but I haven't told it here on You Choose. What's brown and sticky? A stick. Victor, you said you'd be sad on the next one.
Sad. I'm not joking. Look at it. Look. I cannot see it on a camera. No, I do. I did.
Can you cry on demand?
I can. I can laugh and cry on demand. Yes, it's very helpful. Oh my god.
Nailed it. Thanks. High five.
Great.
Bam.
Sorry, just a second.
You missed your calling as an actor, as a drama. Okay, let's say goodbye to everyone. Please, thank you so much for being here. This has been wildly fun, all of it, and I'm looking forward to chapter 2. And I'm gonna have YouTube stickers at KubeCon. I ordered some, and they're here.
Oh,
so
that's
if
new
you
to
see
me
me
even.
or Victor, I'll make sure Victor's carrying some in his badge. Get a YouTube sticker. All right, bye, friends. Goodbye.